Hi there. So today we are going to be looking at just one activity, just a brief overview of it. It's about a pendulum swinging and looking at the curve of its motion, which is a sine curve. And so I'm using Classpad.net, which is a free web-based software. You can do pretty much, anything you want, calculate, graph, geometry, statistics. So we're going to be looking at the graphing features of it and some of the calculations as well. So you can start exploring. You don't need an account. I would recommend creating an account because the activity that I've shared, which you'll see the link in the description below, if you open it and you have an account, you can actually save it, and so you don't have to look for it again, and you can also modify it once it's saved. So I'm going to go right into the activity. So again, it's just a URL, and once you click the URL, it brings you to this activity right here. So you'll see that it is a activity about a pendulum. Here's an example of what a pendulum is. It kind of describes what's happening. Because of gravity, it tends to center over that point, and because of air resistance and friction, the motion doesn't go on indefinitely, it slows down. If we didn't have any of that resistance, it would continue indefinitely. And so then they talk about how the motion, because of the friction and stuff, can actually be modeled with a sine function, and that the amplitude of that sine function, because of the friction in the air, is slowing down. And that's what they're going to be exploring in this activity. So the first thing they're asked to do, and this is where we're going to be using the graphing feature of the Classpad.net, is to actually plug in this equation here. So I'm going to do that, and to do it, one thing you want to check, okay, so there's settings for the whole paper, and anytime you see three dots on anything, on a sticky, whatever, that means settings. And so if I just check math settings, I want to make sure that my angles are in radians, not degrees, which is good, it is. And now we can enter this. Now there's a couple ways. I could just type it out using the soft keyboard here. So you'll notice as soon as I click into the equation sticky, the keyboard comes up, and I have a lot of templates I can use. So let's just start typing. I'm using both my keyboard for my computer, and I could also use the soft template here. So let's do 0.85, and to get that exponent in, I'm going to choose this template and use the X there, and then get out of the parentheses by using my right arrow, multiplied, and 1.3, and to get the trig functions, I'm going to go into math, and you'll see that there's the templates for those. So hit sign and go back to numbers so I can enter my values here, and then execute. And so now we see the graph of this, but notice we might want to work with the window a bit, because we really are only caring about time from 0 on. So and you'll notice that the amplitude is slowly decreasing, and that's because of that motion, the friction that's impacting the motion. So I'm going to actually change the window. So to do that, again, remember 3 dots is settings, and I want to change the window. I really only care about time 0, and we could go up to, let's go up to 10 maybe. And then for Y, we really don't care much about that either. So let's do that. And now I have a slightly, and we can even expand the graph a little bit here. And so now I have a little bit more of a window that I can look at of the amplitude. And so I only care really about this little piece right here, starting at time 0. I don't know what is going on with my graph right now, but it's kind of going crazy. So the first thing they're asked is, okay, so you've graphed it, so can you find where things are at 1 second, 2 second, whatever? So we're going to explore those points, and to do that, when you click on the graph, I want you to notice what happens. When you click on the graph, it brings up key points. Now notice these are in standard form, so I'm going to go back to my settings and change that to decimal, just so I can actually work with it a little bit easier. So you'll notice that this key point here at 0 time, I'm at -1. And so it's asking me for at 2 seconds. So here's 2 seconds, which I don't seem to have a point right on it. So what I want to do is click on my graph and create a movable point, and then move that point till it gets to 2 seconds. And you'll see it's at -0.2 0.66. Now, it looks like the decimals are only going up to tenths. I could change the decimal to be more than fixed at 2, but we'll just leave it at 2. So there would be my answer right there. At x equals 2 seconds, my y position is at negative 0.66. So then that's how they're going to figure out the rest of these right here. And now they want me to graph it again and change the x to 0.0 seconds. So we're going to just kind of explore this graph by moving points around. As they move down, you can actually pull up your table of values now. And they're asking for this initial position, right? And that's at 1, negative 1. So all of these things are coming directly from the graph. And same thing here. They're looking for the peak. So if we go back up to the graph, they're looking for these peaks. So this is peak 1, peak 2, peak 3, peak 4, peak 5. Where are they? So if we take that movable point, we are at the peak at 1, and it's at 0.87, right? And then we would do the same thing. So we're just basically using our points, our tracing ability, to find the peak values for the x and the y. And then what they're going to do is basically take those ratios and convert them. So you're using your graph to find specific values, and then you're going to then use those values that you found to complete ratios and find a constant, an understanding of how the amplitude is changing proportionally at each peak. So that's this whole activity. Relatively easy as far as what you're doing with Classpad. You're graphing, you're tracing points, and then you're doing some calculating of ratios.